In this tutorial, we're going to learn how to use Entityframework to create, design, and query a SQL database. The project example we're going to use is a .NET API for a blogging platform. In this platform, we have a table for all of the users. Each user can have a blog, and each blog can have multiple posts. We'll first create a new API project. I'll show you which dependencies you need to install. We'll configure and create our database using a code-first approach, and I'll show you various tips and tricks as we go along. Next, we'll go over running create, read, update, and delete commands against our database using Entityframework. And lastly, I'll show you some optimizations and tips for using EFCore in a production environment. First, let's open Visual Studios and create a new web API. We'll click Create New Project. We'll search for API, and we'll select ASP.NET Core Web API. We'll name the project. We'll click Next. We're going to use .NET version 6. So we'll keep all these settings as they are, and we'll click Create Project. Now we've created the project, the first thing we need to do is install the Entityframework dependencies using Nuget. So we'll go to the Solution Explorer, we'll right click on the project, and we'll click Manage Nuget Packages. We'll click Browse, and we'll search for EFCore SQL Server. Now, in this tutorial, we're going to be using Microsoft SQL Server as our database, but there are many other database providers that you can use with Entityframework. For example, MySQL, SQL Lite, and even NoSQL databases like Azure Cosmo Db. Even if you do choose to use a different database provider, the code for the project will be largely the same. I've also added some notes in the description of this video if you want to use a different database provider. And now we'll install the SQL Server provider. When you install this package, it comes with the Entityframework base library as well as the Entityframework core relational library, so you don't need to install those. Next, we need to install the Entityframework core design and tools packages for creating and designing our database. So we'll type EFCore tools, and we'll install the tools package. And we'll also install the design package. And the last thing we need to install is the .NET Core CLI tools, which I already have installed. But if you don't have them installed or you're not sure, then all you need to do is go to the developer PowerShell for this project, which is already in the correct directory. Paste in this command, which I've put in the description, and press enter. You can see I already have it installed. That is how you do it if you don't. Now that we've completed installing the packages, we can get started designing our database. Now we're going to create some C# models in our project and use those with Entityframework Core to create our database and tables. This is called a code-first approach to Entityframework. Something we aren't going to cover in this tutorial is how to use Entityframework with an existing database that already has some tables and data in it. Now, I've added some links to the description of this video if that is what you want to do. We'll get started by adding a folder called Models. As I've said, for this project, we're going to create an API for a blogging platform. On this platform, we're going to have a user table, which is for the details of all the users that have a blog on our service. So that's the first model that we'll create. We'll right click on the folder, add, class. We'll call it user. And now we need to enter all of the properties that we want our user entity/table in our database to have. First, we'll add a public int user ID. Now this will be the primary key of the table. Next, we'll add a field for the first name, last name, email address, about me, and then a date time, which will be used to specify the date time at which the user was created in the database. Now, before we create any more models for the blog and the blog's posts, I'm going to finish off the rest of the entity framework configuration so we can create our database and table with this model, and then we'll come back to creating the rest of the models and our database structure. So the next thing we need to do is create a DbContext class. This is one of the most important classes in an entity framework project, as we'll use an instance of this class to run queries against our database. We'll right click, add class, and we'll call it application DbContext. Now, the application DbContext that we create must use the entity framework DbContext as a base class. This base class contains all of the code we need for configuring and querying our database. It must also have a public constructor that accepts the class DbContext options, which we'll use to tell the context where our database is located using a connection string. This is a generic class which accepts a type of our application DbContext. We'll call it options. We need to pass those options to the base class. Lastly, we need to tell the context which models are in our database. So whenever we create a new model, like we just did with the user model, we need to create a property in the context using the DbSet entity framework class. So we'll write public DbSet. This is also a generic, except here we type the name of the model we created. We'll name it users. When we give the property the name users, this will be reflected in our database so that the table will be called users. There are also other ways to change the name of the table, which we'll look into. Once the DbContext class has been created, we need to register it using dependency injection so it can be accessed within our API project. By registering the DbContext using dependency injection, every time our API receives a new HTTP request, an instance of our application DbContext class is created, and once the HTTP request is complete, the context will be disposed of. Using Entity Framework in an API project is actually quite easy compared to other projects. For example, if you were creating a Blazor server project that was using Entity Framework, then you would need to configure the dependency injection for your DbContext differently. So we'll go to the program.cs file. Before the builder.build command, we will write builder.services add DbContext of type application DbContext, and we'll pass in an options object. And here we want to pass in a connection string which points to the location of our database. We're going to store our connection string in appsettings.json. So we'll use the configuration.getConnectionString method. And I'm going to name the connection string blogging database. Now we need to go to our appsettings.json file and add a connection string called blogging database. And we'll paste that. We are using a local version of SQL for development purposes. If this was in a production environment, we would need to change this connection string to point to our hosted instance of SQL Server. Now we've finished creating the DbContext and connection string, we can use Entity Framework to create a new database with a table generated from the user model we created earlier. To do this, we need to create a new migration using the add migration command. To do this, we go to the package manager console and we type add migration. We give the migration a name. We'll call it initial setup. And optionally, you can add -verbose, which will give you a more detailed output in case of errors while adding the migration. We'll run that command. Now, before we take a look at that migration, I just want to mention that Another way to run these Entityframework commands is using the developer PowerShell. First, you need to make sure you are in the directory of your project that contains the csproj file. So we're going to change directory to EFCore tutorial. And we can see here, we're now in the directory. If we wanted to add a migration using PowerShell instead of the package manager console, we would have to use the .NET CLI by typing .NET-EF, and then we can type the command that we just typed into the package manager. Now, I'm not going to run this command since we've already created the migration, but I just wanted to show that there are two different ways you can enter these commands depending on if you want to use the package manager console or PowerShell. So as we can see, a migrations folder has been created in the Solution Explorer, and we have a migration which has the name that we gave it, which is initial setup. Now, migrations are used to incrementally update your database. Every time you make a change to your models or you add a new model, you have to create a migration, which is then used to apply those changes to your database. If we take a look at this migration, we can see there is an up method and a down method. The up method contains C# code which will apply all of our model changes to the database when we run the update database command. So we can see we've got the code for creating a table called users, and that table has all of the fields that we defined in our user class. Also identified that we have a primary key called user ID. The down method is used to revert the changes from a migration if you no longer want them. And we're going to look into reverting migrations soon. Now that we've had a look at our migration, let's run the update database command. This will create our database since it doesn't exist yet, and also apply the initial setup migration, adding the user table to our database. We'll go to the package manager console and we'll type update database. And there we go, we can see the database has been created and the migration has been applied. Let's take a look at that by using the SQL Server Object Explorer. Depending on what database you're using in your project, you may need to use a different piece of software. We're going to have a look at the MS SQL Local DB, since that is the server we supplied in our connection string. We'll refresh the databases section. And we can see there's a new database called EFCore testproj, which is the database we provided in our connection string. If we open that and take a look at the tables, we can see there is a user table, which is called users, and it contains all of the columns we provided in our user model with a primary key called user ID. You might also have noticed that there is a table called EF migration history. This table is used to show which migrations have been applied to your database. This is useful for debugging when you're getting errors trying to apply migrations. Next, I want to show you how to apply updates to your database. Let's say, for example, that we want to add a new field to our user table. First thing we do is go to our user class. We'll add a new property. Middle name. Then we simply add a new migration. We'll name it user table middle name update. Here we can see a migration has been created for this change, and you'll notice that this migration only contains the middle name change that we just made. It doesn't contain the code for adding the user table, adding the rest of the fields. Entityframework detects what changes have been made and just generates the code for that. We'll apply this migration to our database by typing update database. And if we take a look in the SQL Server Object Explorer, we can see the middle name field has been added to the users table. Now let's say we're not happy with this middle name change that we've just made and we want to remove it. The first thing you have to do is revert your database to the previous migration, which in this case is the initial setup migration. To do that, you type update database, and then you enter the name of the migration that you want to revert your database back to. Then if we take a look, we can see the middle name field has been removed from the users table. Then we need to remove the migration that we're not happy with. To do that, we just type remove migration, and this will remove the last migration that was added to the project. And we can see here in the migrations folder that it's been removed. The last thing we need to do is remove the change from our user class. Now, in some cases, you might have removed the migration because you've made a mistake. Let's say, for example, you spelt middle name wrong, or you gave it the wrong type, for example. If that were the case, then you would simply make those changes in your user model, and then you would just re-add the migration, run the update database command, and then continue with your development. In this case, we're going to assume that we are no longer happy with this change and we don't want to have a middle name anymore. We'll have to remove it from the table. If we don't do this, then when we come to running a migration again, the middle name will be picked up and applied to the database. So we need to make sure we remove it if the field is no longer needed. Next, I want to show you how to generate a SQL script from a migration. Let's say, for example, you're working in a production environment where you can't apply these changes directly from your machine. You need to send a script to another department and then they apply the changes to the database. If that was the case, then we simply use the script migration command. And we need to provide a name for the file because this command is going to create a SQL file which we will be able to see in the project solution. And there we go. So we can see the SQL for this migration has been generated. We can see we've got the SQL for creating a table, a SQL for creating the migration history if it doesn't exist yet, and some SQL for inserting which migration this was. I'm going to end this part of the video, but please watch on to the rest of the Entityframework playlist. We're going to go over data annotations, database and table relationships, querying the database within our API, and also some tips and optimizations for using Entityframework in a production environment.